Thank you for joining me. Thank you for watching the 2.8 notes video. Today what we're going to start focusing on are two variable inequalities. Now the way that we solve these is we're going to be graphing these and finding the solution region. So we're going to start with a little introduction. We're going to jump right into a word problem to show you how these can be applied. So our word problem. You're going to throw a party and provide hot dogs and hamburgers. Hot dogs are $2 per pound and hamburgers are $3 a pound. How much of each item can you buy if you don't want to spend more than $60 on meat? So, the first thing I'm going to do, I'm going to jump down right to here. Okay, so the first thing I want to do is I want to consider what is being asked of me. All right, what am I trying to find? Because that's going to tell me what my variables are. So, I have two things that I need to find. The first thing is I want to know the number of hot dogs that I'm buying. And then the second thing I want to find, the number of hamburgers that I'm buying. So that's how I want to start these problems. Whenever I do a word problem, I want to identify what variables do I need? What am I trying to find? And now what we're doing is we're determining cost. Well, sometimes the easiest thing to do is use real numbers. Play around with some real numbers and then figure out, all right, where does my variable fit into this? So I'm going to pretend that I need 2 hot dogs and 5 hamburgers, all right? So if I'm buying 2 hot dogs, well, that means I'm spending $2 on each one. So I'm going to spend $4, okay? $2 for each one. And then if I'm buying 5 hot dogs, well, I take the $3, and if I'm buying 5 hot dogs, I'm paying that 5 times. So 3 times 5. All right, so how much am I spending? Well, $4 on the hot dogs, $15 on the hamburgers. So I'm spending a total of $19 as is. All right. So now that's what this would look like if I were buying precisely that many. Well, now I need to figure out where do my variables belong. So X is representing my number of hot dogs. So what did I do? Well, I'm paying $2 per hot dog. Then I multiplied that by the number that I was buying. So I ended up paying 2x for them, okay? And if I look at my hamburgers, well, I had to pay $3 per hamburger, but then that 5 came from, because that's how many I said I was buying in my hypothetical scenario. And that's going to total the cost. Well, we want the cost to be less than or equal to 60. You don't want to spend more than 60. So that's one way you could do this, all right? You could use real numbers and then later go back and fill in the variable. Otherwise, you may remember those words per that I would always identify in earlier chapters, okay? That per represents a rate, so you know that that number is connected to your variable. So either way you'd like to remember this, that's how you'll go about these problems. Now, in order to actually graph the solution set, well, we only know how to graph things in y equals mx plus b form. So what I'm going to do is I'm going to get this in y equals mx plus b form. So I'm going to subtract 2x from both sides. So 3y equals negative 2x plus 60. Divide by 3, negative 2/3 x plus 20. And I'm sorry, I ended up changing the inequality sign. It should look like that. Okay, now, in order to graph this, the first thing we have to realize is x is the number of hot dogs. So hot dogs goes down here, and hamburgers is my y. So hamburgers goes along the side there. Now the first thing is we start at the y-intercept. So I'm going to plot that 20 first. And it just fits right there. And now I have a slope of negative 2/3. So that slope of negative 2/3, what that means is I'm going down 2 and over 3 for every one of these. All right, so I'm going to follow my slope. Just like that. Now, oh, I apologize. I actually messed up on that one point. Now, when you're doing inequalities, don't get too hasty, all right? Because in order to draw our line in, there's something we have to consider. So, for those two types of signs, that means we're going to get a solid line. For those two signs, we get what I call a dashed line. That's how we represent the inequality. Instead of open circle, closed circle, it's solid line or dashed line. So, I look at my inequality symbol, and it is less than or equal to. So that means I actually do get a solid line. And the next thing I want to consider is where I do my shading, because this time we're shading a whole region. Okay? So, RY is less than or equal to. So what does that mean? Well, that means that I need to shade less than or equal to that line. Well, so I'm going to go to any point on the line, okay? Any point on it. And where is less than that line? Well, down there. All right, so what I'm going to realize is less than the line. I'm going to start at any point and then go underneath it. And that means that this whole region here is going to represent my solution. So that's the gist of how to do these inequalities. Is plot some points, see if you need a solid or dashed line, and then determine which area above or below are you going to end up shading. So now we're going to do quite a few of these problems to get some good practice in. So the first thing that I'm going to do here is oftentimes students have a much easier time seeing this when the x comes first. So I haven't done anything fancy. I haven't really done any math. All I want to do is write it in the mx plus b form, so with the x term first, because I think that makes it a little bit easier for you guys to see what's going on. So as always, I'm going to graph this starting with my y-intercept. So I'm going to start up at that 4, okay? Now, slope of negative 3, and again, you can consider that negative 3 over 1. So slope of negative 3 over 1, rise over run, down 3 over 1, down 3 over 1, down 3 over 1, and you can do the actual reverse of that as well. And now, the next thing I'm going to do, I'm going to look at the sign of my inequality. Greater than or equal to. So that or equal to piece, if you recall, means I get a solid line going through there. And now, this time, my y is greater than the line. So I'm going to look greater than the line. So I'm going to start at any point and ask myself, where's greater than that line? Well, greater than means above. So what does that mean? Well, that means I'm going to be shading where that arrow points. I'm going to be shading above my line. and I get that entire region there as my solution. So continuing right along. So graph 4y minus 3x is less than 15. Now, to make this problem more doable, because I don't like having fractional y-intercepts, why don't you guys go in, just change that to a 16 for me, please. Okay, again, I want this to be, to turn out to be nice numbers. So, if you would please change that to a 16 for me. Now, the problem here, as you probably know, is in order to graph this, we need it in that slope-intercept form. And as of now, it's not in that proper form for us. So the first thing I'm going to do is I'm going to solve this equation for y. I'm going to get it into that slope-intercept form. So what that means is I'm going to add 3x to both sides to cancel that. So I've moved my x. Next, I'm going to divide everything by 4. So now my line is graphable. 3/4 x plus 4. So again, as always, what are we going to do? Well, the first thing, we're going to plot that y-intercept, that positive 4. So that's going to be the first thing that I take care of, plotting the positive 4. Next, I'm going to look at my slope, 3/4. So rise over run. For every 3 I go up, I go over 4. That'll land me that point right there. Or again, you could do the complete opposite. Now, it's time to identify. So here, strictly less than. So there is no or equal to portion. It is just less than. So that represents, back with one variable inequalities, the open circle. Well, we can't do an open circle here, so what we end up doing is a dashed line. That represents that the line itself is not actually part of the solution because it is just less than, not less than or equal to. And the next piece, so if y is less than my line, I go to any point and I ask myself, well, less than means below or under. So in order to do this, I'm going to graph less than that line, underneath that line. And that means all of this down here becomes part of my solution set. All right, looking at our next one. So here again, the first thing that I'm going to want to do is I'm going to want to solve this for y. Now, the only thing that is happening to y is it's being multiplied by -6. So I'm going to divide both sides by -6. So I get y by itself, and I get -2. Now, don't forget here, when you multiply or divide by a negative number, which I just ended up dividing by a negative number, when you do that, don't forget to flip the direction of the inequality. So we get something that looks just like that. Y is greater than -2. Now, I hope you also remember from our little graphing review day, this is a special case. When you just have y and there's no x, remember that is going to give us a horizontal line. So, now before I draw in that line, I also want to consider my sign, greater than. All right, so strictly greater than means it's not including my line, so I'm going to get a dashed line. And where is a dashed line going to be? Well, my dashed line is going to be down at a horizontal line at -2. 2. Okay? And y is greater than that line. So, greater than, go to any point. Greater than means above. So if y is greater than that -2, that means I'm going to get every point in this region here. All right, so I think I'm going to call it good for this first notes, all right? That's as far as I'm going to take us. So thank you so much for joining me, and we will wrap up these notes in the second part of the note video.